What's up, guys? My name is Mr. Meehan, and today we are talking about Unit 2, Lesson 4. It says, I can show that two lines on a coordinate plane are parallel or perpendicular by comparing their slopes and use that information to solve problems. So right into some review here. It says, given 2 points, 2, 2, and 5, 4 on the coordinate plane, answer the following questions. It says, what is the rise? The rise is how far up or down, like the change in y values that's happening. So the change in y values here looks like it goes up 1, 2. So the rise is 2. The run is the change in x values. So like left or right, and it looks like we're going right 1, 2, 3. So the run is positive 3. What's the rise over run? Well, that's 2/3, and we call the rise over run the slope. The slope can even be represented as the letter m sometimes, okay? So how could you figure out the slope without using the graph? Slope formula. All right, so we have this slope formula. It says the slope m is equal to y2 minus y1 over x2 minus x1. So given 2 points, where one of the points is 0.1 and one of the points is 0.2, we can use this slope formula to figure it out. So up here it says we have 0.22 and 5, 4. All right, let's see if we can figure out the slope of this just using the slope formula, okay? So let's say this is 0.1 and this is 0.2. Our slope here is then going to be y2, so that's 4, minus y1, which is 2. And then we're going to get x2, which is 5, minus x1, which is 2. So we'll get 4 minus 2 is 2, 5 minus 2 is 3. So we get 2/3, and that's what we got earlier when we did rise over run, right? This matches up to this, so we know our formula works. So whenever we're given 2 points and it says, hey, find the slope of these 2 points, we could use the slope formula, okay? All right, Mr. Meehan, that's me, and his good friend Sean Kingston are walking to McDonald's from Fenwick. They both start at the same time, but Mr. Meehan had a 3-kilometer head start on Sean Kingston. The tables below show the distance from Fenwick after a set amount of time. So at 0 minutes, I was already 3 kilometers away. At 2 minutes, I was 4 kilometers away. At 6 minutes, I was 6 kilometers away. Sean Kingston at 0 minutes was 0 kilometers away. At 4 minutes, he was 2 kilometers away. At 6 minutes, he was 3 kilometers away. All right? So if we say time is x and distance is y, can you graph each set of data to form lines? So let's do it. This is time, and this is distance, right? Distance. All right? Let's graph it. So let's graph my line. We'll graph mine in red, let's say. So at 0 minutes, I was at 3 kilometers. At 0, I was at 3. At 2 minutes, I was at 4. At 6 minutes, I was at 6. 6 minutes, I was at 6. At 12 minutes, I was at 9. 12 minutes, I was at 9. All right. 20 minutes, I was at 13. All right. Then we can connect those dots to make a straight line like that. Now let's graph Sean Kingston's path here, and we can do that in green. So at 0 minutes, he was at 0 kilometers. At 4 minutes, he was at 2. At 4, he was at 2. At 6 minutes, he was at 3. At 16 minutes, he was at 8. 16 and 8. And at 20 minutes, he was at 10. 20 and 10. All right. And we can connect those dots. All right. What is the slope of each set of data? Let's figure it out. Let's use rise over run here. So if I wanted to find the rise of the red line, we would start here and go, let's up 1 and go to the right 2. So the rise of the first one is, let me use red here. The rise is 2. No, the rise is 1. The run was 2. So the slope is 1/2 of the red line. The slope of the green line, let's see. We go up 1, 2 over 1, 2, 3, 4. So the slope here would be 2 over 4, which is really equal to 1/2. So the slope of each set of data is the same. They're both equal to 1/2. Whoa, what happened? Here we go. All right. Slope is equal to 1/2. What do we know about lines that have equal slopes? Well, if you remember kind of from algebra, So lines that have equal slopes are parallel. Parallel. Parallel lines have equal slopes, the same slopes. So, will Mr. Meehan and Sean Kingston ever be the same distance away from Fenwick? No. Because the paths are parallel. They're never going to intersect. So, let's say the paths will never intersect. There we go. Some review here. It says an electrical power line travels up a hill and the wires are 20 feet above the ground at all times. Both the power line and the hill have a slope of 1/2. The graph below demonstrates this, and I drew this beautiful graph. It says, what is the y-intercept of the power line? The power line is this black line up here, and the y-intercept is where the line crosses the y-axis, right? Where it intercepts the y-axis. So where does it intercept the y-axis here? It looks like at about 20 feet. So let's say the y-intercept is 20. Now, what is the equation of the power line in y equals mx plus b form? Well, let's see. Y equals m. What's the slope here? M is the slope, and the slope they gave us is 1/2. So for m, we're going to put 1/2 times x plus b. B is the y-intercept. What was the intercept that we found? We found it was 20. So the equation of the line is y equals 1/2 x plus 20. All right? Now, what's the y-intercept of the hill? Where does the hill intercept the y-axis? It looks like at 0 feet, so let's say 0. What's the equation of the hill at y equals mx plus b form? Well, let's write it out. Y equals mx plus b. M here, it says the hill and the power line have the same slope. It's 1/2. So y equals 1/2 x plus 0. Or if you wanted to, you could just leave it as y equals 1/2 x. All right? Because 0 is the y-intercept. Make sense? So these two lines are parallel since they have the same slope. Same slope here, same slope here. Those lines are parallel. All right, and then step 5. I answered the question too soon. What conjecture can you make about the power line and the hill? They are parallel. They're never going to intersect, right? If the hill was steeper, what would happen to the slope of the equations? Well, then the equation's slope, the slope would get bigger. The bigger the slope, the steeper the hill, basically. The steeper the line, the bigger the slope. All right? Here are some parallel line theorems. Two non-vertical lines are parallel if and only if their slopes are equal. So that's a biconditional, right? Because it says if and only if, so it can go either way. Two non-vertical lines are parallel if and only if their slopes are equal. So if P and Q are both not vertical, then P is parallel to Q if and only if the slope of the line P is the same as the slope of the line Q. So it's basically saying if two lines have the same slope, then they're parallel. Step 2 here says any two vertical lines are parallel. So if P and Q are both vertical, then P is parallel to Q. We have to have these two separate versions of the parallel line theorem because vertical lines, they don't really have a slope. Their slope's undefined because it goes straight up and down. So the rise goes on forever. And then the run is 0. All right? And you can't really divide anything by 0. So the slopes are undefined. But still, these lines are parallel. So that's why we have the two separate parts. So examine the graph here. It says, is line K parallel to line N? In order to figure out if they're parallel or not, we have to figure out the slopes of each line. So line K, let's look at the line K and see where it intersects the grid on the coordinate plane here and pick some points. So it looks like this graph is pretty blurry, so you got to excuse that. But looks like 1 point for line K is -2, 2. And then a second point is 2, -3. So the slope here for line K, we could say is -3 minus 2, and then 2 minus -2, which will be -5 over 4, and that's it. Remember, I'm just using the slope formula, which is y2 minus y1 over x2 minus x1. Let's then pick some points on line N. Let's say we have a point here at 1, 2. 1, 2. And then we have a point at 4, -2. All right. So if we wanted to find the slope here, we could say we have -2 minus 2, and then 4 minus 1. So we have -4 over 3. So look at that. We have different slopes. We have a slope here that is -5/4 and a slope here that is -4/3. And so these lines are not parallel. Although on the graph they look parallel, at some point in time they are going to intersect because they have different slopes. Let's try line M and Q. M here, let's pick some points. It looks like maybe -1, 4 and -4, 3. So -1, 4 and -4, 3 we said. And then let's say we're looking at line Q now. So let's say 1, 0 and then -4, -2. All right. So let's figure out the slopes. So the slope of M, that's going to give us, let's see, 3 minus 4, -4 minus -1. That'll be -1 over -3. That's 1/3. All right. Then the slope of Q, let's see, -2 minus 0 over -4 minus 1. -2 over -4 equals 1/2. So again, M and Q, really, I think they look parallel on the graph, but they aren't parallel because they have different slopes. At some point in time, they're going to intersect. We may not see it right now, but at some point in time, if we extended that graph long enough, they're going to intersect. All right, so given the graph of two perpendicular lines, are perpendicular lines parallel? And I know that sounds like a crazy question. Obviously, they aren't parallel because they're intersecting, but let's figure out the slope of each line just to see. All right, so let's look at some points. It looks like we have a point, let's see, at 0, 1, and then we have a point at 1, -3. And then if we looked at the other line, it looks like we have a point at 0, -2. And then we have a point at -4, -3. So let's figure out if these perpendicular lines are parallel. And again, it may seem kind of like a silly idea, but we're just kind of proving it here for ourselves. So we can do the slope here. It's going to be -3 minus 1 over 1 minus 0, which will give us -4 over 1, so -4. So the slope of that first line is -4. Let's do the second line. We will have -3 minus -2 over -4 minus 0. That'll give us -1 over -4. That'll give us 1/4. So we know these are perpendicular lines, and we just now have proved that perpendicular lines are not parallel. Since those slopes are not the same, the slope right here, -4, is not the same as 1/4, then perpendicular lines are not parallel. It then says, though, how are the slopes of two perpendicular lines related? Well, this is kind of the interesting part. If you had two perpendicular lines, the slopes here, let's say the slope of the first one is x over y. Let me use a different color. X over y. All right? That would mean the slope of the second one is going to be -y over x. All right? So the slopes of two perpendicular lines, how are they related? They're opposite reciprocals of each other. So you take the reciprocal, you flip it upside down, and then you add a negative sign on it, okay? So look at this. If you look at our yellow highlighted area, let's see, right here, we have -4 over 1, right? So pretend that's -4 is x and pretend that 1 is y. If you then look at the red highlighter over here, it's in flip-flop, so it's opposite reciprocal. So now it's 1/4. So you can see that we just showed the slopes of two perpendicular lines are related because they're opposite reciprocals of each other. So perpendicular line theorems. It says two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if P and Q are both not vertical, then P is perpendicular to Q if and only if the product of their slopes is -1. And you may be thinking, wow, that's coming out of nowhere. It's really not, though, because if you look at the two slopes that we just found here for perpendicular lines, if you did x over y times -y over x, well, you would get -yx over yx, which is -1. So the products of two perpendicular line slopes are -1. Part 2 here says a vertical line and a horizontal line are perpendicular to each other. So if P is vertical and Q is horizontal, then P is perpendicular to Q. And again, we kind of have to have the second part because the slope of a vertical line is undefined. So it makes it kind of hard to put into this theorem just in general. So we have to have the part twos, okay? All right, so given the graph, is line K perpendicular to line J? So we got to figure out some slopes. Let's do line K. Let's figure out some points. It looks like we have -2, no, -3, +2. And it looks like we have, let's say, 0, 4. Okay? And then let's also look at, let's see, line J. That is this line right here. So line J, we have a point at 3, -1. And then we have a point at 1, 2. So let's figure out the slopes. The slope of the first one, line K, is 4 minus 2 over 0 minus -3. Looks like 2 over 3. So if these are going to be perpendicular, we would like to see in line J, the green line here, we would like to see -3 over 2 if we want them to be perpendicular, okay? So let's see what we get. Looks like we're going to get 2 minus -1 over 1 minus 3. So 3 over -2. Which is really -3 over 2, right? So that's exactly what we got. Are these lines perpendicular? Yes, they are, because they have opposite reciprocal slopes. Let's do it on another pair of lines. H and L. Line H, let's pick some points. How about -2, -1? And then we have, let's see, 1, -3. Let's look at line L. That's this line right here. We have 3, 2. And then we have, it looks like they share the point 1, -3. All right, so let's try it. -3 minus 1, sorry, minus -1 over 1 minus 2, sorry, minus -2. So -3 minus -1 over 1 minus -2. That gives us -2 over 1. -2 over 3, my bad, -2 over 3. So again, if we have -2 over 3 for the first line, then for the second line, if we want them to be perpendicular, we should get 3 over 2, +3 over 2. So let's try it. Slope here, -3 minus 3 over 1 minus 2, -6 over -1, so that's just +6. So are these lines perpendicular? No, they are not, because the slopes are not opposite reciprocals of each other. Last one, is line K perpendicular to line M? Well, we already have the slope of line K. We did it up here. It's 2/3. So let's just figure out the slope of line M. And let me get a different color here. Let's do purple. Line M, looks like we have a point at 1, -1. And we have a point at, let's see, 0, 3. So if we found the slope here, we would get M equals 3 minus -1 over 0 minus 1 equals 4 over -1 equals -4. All right, so is 2/3 and -4, are they opposite reciprocals of each other? No, so K and M are not perpendicular. All right, so given the graph, it says what is the equation of the line through point P that is parallel to line L if we know point slope form is y minus y1 equals m times x minus x1. All right, so point slope form is really easy. All you need is one point and one slope. It gives us the point, it gives us point P, and it tells us that it's going to be parallel to line L. And we know the slope of line L is 1/2. It tells us that in the equation. So what we're going to do is we're going to take our point slope form and plug in the numbers that we have. So our point P, the point that we plug in, that's x1, y1, okay? So y1 is 1, so it should be, say, y minus 1. M, since we're doing parallel to line L, is going to be 1/2 times x minus x1. x1 is 4. So what is the equation of the line through point P that is parallel to line L if we know point slope form is that? That's it. It doesn't say to simplify this equation, so we can just leave it like this if we wanted to. However, if we wanted to simplify it, we totally could. We could say that this is y minus 1 equals 1/2 x minus 2, which would then bring us to y equals 1/2 x minus 1. So that would be our what do we call it, y-intercept form, right? Our next one says, what is the equation of the line through point P that is perpendicular to line L? So again, we're going to use the same point P, so we can plug in those points. We can say y minus 1 equals, let's leave m for now, x minus 4. But if we're doing perpendicular to line L, instead of using the same slope, we're going to use opposite reciprocal of the slope. So if the slope is 1/2, we take the opposite reciprocal, which is going to be -2. So again, that'd be our final answer, unless it tells us to simplify it. If it does say simplify it, that's super easy to do. Y minus 1 equals -2x minus, actually plus 8. Y equals -2x plus 9. All right, last couple examples. It says, given the equation for line K is y equals -3x plus 2, and a point T is 3, 1, can you determine the equation of the line parallel to line K, which passes through point T? We totally can. This is the same exact problem that we did above, except now it doesn't give us the graph, okay? So if we're using the y-intercept form, or point slope form, I should say, my bad. The point slope form is y minus y1 equals m times x minus x1. So let's just plug and chug, plug in what we know. We're doing parallel to line K, so that means we're going to be using the same slope as line K. Y1 here is going to be 1. M is the same slope as line K, so -3. And then times x minus x1, which is 3. So then if we wanted to simplify, we'd say y minus 1 equals -3x plus 9. So y equals -3x plus 10. Cool. Point 2, number 2, it says determine the equation of a line perpendicular to line K which passes through point T. Only difference here is we're now perpendicular. So we'll do y minus 1 equals, I'll leave that blank for now, x minus 3. The slope here is the only thing that changes. So instead of being the same slope, we're now taking the opposite reciprocal of the slope of K. So the opposite reciprocal of -3 is positive 1/3. If we wanted to simplify this, we could say y minus 1 equals 1/3 x minus 3. Y equals 1/3, sorry, that should say minus 1, right? 1/3 times 3 is 1. So y equals 1/3 x minus, actually, it'll just be like that, right? If you add 1 to each side. So y equals 1/3 x is your final answer.